Yeah, dear student of class 12. Today, now I am going to tell you some applications of Biot-Savart law. Actually, I advise you to read the syllabus of the class 12 of every exam wherever you go. Have copy of syllabus with you first. But there are some topics which are indirectly involved with the syllabus. If we are studying Biot-Savart law, then any application of Biot-Savart law can be asked. Actually, in book this topic is not given this year now. In our current NCERT book, this heading is not there. But we can't understand the physics of magnetic field due to current in coming topics. So I take this topic here and try to explain, because you will understand the basic physics behind the application of Biot-Savart law on magnetic field due to straight long current carrying conductor. Current I is passing through this long conductor. Long means infinitely long. Long means infinite long. And how it is infinite long? It is shorter than the board. Actually, the distance r is with respect to this distance r. This length is infinitely long. Don't confuse with this word infinity. Infinity means some large length with respect to smaller length in physics. We can say by distance of moon from earth, though it is measured, distance of sun from earth, distance of sun 1.5 10 11 meter. But when we talk in terms of focal length of lens, the sun is supposed to be at infinity before lens, and you can obtain image of sun by convex lens on thin sheet of paper. Now, like that. So please understand the meaning and things first. So in figure here we have a long conductor carrying current I. We want to find out field at P at distance r from center of the long wire. This long wire carrying current I, we want to find out field at distance r. For this r the length is infinity. So how to find this field here? So I have taken this element dl, because Biot-Savart law is for small element, not for whole length. Be careful. Biot-Savart law determine the magnetic field due to small length. So if I consider this length dl here, which distance this from P x position vector. So from Biot-Savart law, magnetic field at P due to small element of length dl is given by vector dB is equal to mu0 upon 4 pi I dl cross, now position vector is x not r, x upon modulus x cube. Please learn. Actually, sometime in exam, question is asked of 1 mark. State Biot-Savart law. So you write directly according to Biot-Savart law, magnetic field due to small length element given by this. Explain the meaning mu0 magnetic permeability, I current dl length element x position vector. That's all. Now magnitude of direction of this field. किधर होगी भाई? Direction of this field. Direction of vector dB according to a right-handed screw rule. Right-handed screw rule for vector product. Is normal to plane. You will write plane of paper because here board. I assume board as a plain paper. Plane of paper and into it. यानी कि why it is so? DL cross R. DL direction this way or R this way, so DL cross R clockwise, so screw goes inside into it. So we mark cross the magnitude of this field and magnitude dB is equal to mu 0.4 pi I dl x cancel हो जाएगा dl sin theta and x square. Now you will get magnitude this only of this length element. Direction inside the plane of board or plane paper, and this is the magnitude. Now to find the magnitude of magnetic due to whole length, we integrate this distance with respect to minus infinity, this is plus infinity, according to our sign convention of xy axis. So magnetic field due to whole length, magnetic field due to whole length due to whole length is obtained by integrating dB within limits minus infinity plus infinity. That is B is equal to integration minus infinity to plus infinity dB indicate equal to mu 0.4 pi I dl sin theta upon x square minus infinity plus infinity. Here I is constant, mu 0.4 pi constant. We can take them outside. Mu 0.4 pi and I and integration minus infinity plus infinity dl sin theta upon x square. Now here you may feel little difficulty because till now you have not studied integration. So here dl is one thing. Actually the thing is like that x to the power n dx. X to dx here. यहाँ dl यहाँ theta. So we have to change the variables. Here it is x. But x will vary also if we come from infinity. So x will be changing. So we take one, we convert this equation into one variable. Equation 2. Now, in figure, to integrate this thing, we do some, see in figure, theta plus phi angle is equal to 90. So theta equal to 90 minus phi, and hence sin theta equal to sin 90 minus phi equal to cos phi. वैसे तो understood है, लेकिन मैंने just to explain you. Now L upon R Now we'll convert this into phi angle. L upon R is equal to tan phi. L upon L कर दिया और dl equal to dr sec square phi d phi. Differential of tan phi d upon d phi of tan phi equal to sec square phi. जी है ना और d phi वैल्यू पर गया and there is x. ये भी in terms of r क्या होगा x upon r. This is x upon r. For this it is sec phi. X in x equal to r sec phi. Now putting these values in equation 2. Now when we change this value, theta change from phi, so limit will change minus infinity will be minus phi, and this will be plus phi. So putting all these values in equation 2, what we get? We get b equal to mu 0 I upon 4 pi minus pi by 2. Pi by 2. dl, in place of dl we use what? dl is equal to क्या लिखा है? Sorry. dl is equal to r sec square phi d phi. In place of dl r है भाई sec square phi d phi and sin theta cos phi upon x square equal to r square sec square phi. Now problem has been reduced very simple now. 4 pi I upon mu 0. Oh, 4 pi mu 0 I upon 4 pi integration minus pi by 2 pi by 2 sec square phi cancel, r cancel, so we left here cos phi d phi upon r. This r is also fixed distance, this is also constant, so what you can do, mu 0 I upon 4 pi r and minus infinity pi by 2 to pi by 2 cos phi d phi. इंटीग्रेशन cos phi d phi यानी कि इंटीग्रेशन cos x dx एक्चुअली sin x. तो यहाँ पर ये क्या होगा mu 0 I upon 4 pi r और लिमिट लगेगी तो ये होगा sin phi अपर लिमिट pi by 2 लोअर लिमिट minus pi by 2 mu 0 I upon 4 pi r into sin pi by 2 minus sin minus pi by 2. Now it is little difficult for bio student, but you can remember this much. There is one formula for trigonometry, कि sin minus theta equal to minus sin theta. तो ये माइनस यहाँ आकर का प्लस हो जाएगा. So we get here what? b equal to mu 0 I upon 4 pi r और sin pi by 2 1 और प्लस 1 है भाई. sin 91 होता है, pi by 2 sin 90. तो this b come out to be mu 0 I upon 2 pi r. Now you know the mu 0. I have told you mu 0 4 pi 10 to the power minus 7. है भाई. तो this is formula for magnetic field due to long conductor. near the midpoint. Near the midpoint. If someone asks you, okay, what is the field at end point? ये long conductor है, तो you can imagine that half of this infinity. So therefore, magnetic field due to long conductor, long current carrying conductor, at near the end point, near the ends. क्यों एंड यहाँ भी है? That b equal to half of this. That will be mu 0 I upon 4 pi r. Reduced to half. So this is the formula for magnetic due to straight long current carrying conductor. Very useful in learning this chapter further. We will learn other law of magnetism which can be proved by this formula only. Please remember this magnetic field due to straight long conductor is given by B equal to mu 0 I upon 4 pi r, 2 pi r, and at ends it is direction is most important. Here I told you we can use vector product rule, dl cross r या dl cross x जो भी होगा according to that. If we have horizontal long conductor here carrying current from east to west, then magnetic in the north. So dl is this, x this or r this. So dl cross r screw downward. Please don't depend on right hand thumb rule. Depend on this formula dB equal to Biot-Savart law tells you the magnitude and direction of current due to small length. So direction of dB is alone according to dl cross r. That's why I ask you to learn cross product carefully. Cross product will help you in understanding. Once a year there was 3 questions based on cross product in NEET exam. The student could not answer 3 questions who were not knowing cross product exactly. So this was about the one application. Second application I will take next video.